So this is looking at how much chocolate is eaten around the world and how many countries have how many Nobel laureates, Nobel Prize winners. All right? And basically seeing is there a correlation between eating chocolate and having Nobel Prize winners in your country. So if you look at this and you try to find a line, it would probably be, somewhere in there. Now, if you say, well, I think Sweden might be an outlier, you might think that, but look at Sweden and look at Germany. They're kind of about the same distance away. So since it's kind of equally represented on both sides of the line, even though you got a couple that are further out, we don't look at those as outliers. All right? They're just further along, but they are kind of equally matched on either side. So there is a line somewhere in there. So how would we interpret this with an R of 0.791? Well, we'd say there is a positive, moderately strong, and you can abbreviate if you want, moderately, linear correlation, because you could draw a line through there. You can abbreviate correlation if you want, COR, period. Between, and you just say, chocolate, I'm going to abbreviate that, chocolate consumption. I'm going to abbreviate that like that, and Nobel Prizes. Okay, very simple. It's moderately strong. Would you like an 80, 79%, 80% on a test? That's a pretty good grade. So it's moderately strong. There's a line in there, all right? And it's a positive line. All right, now, if people in the U.S. started eating more chocolate, can we expect more Nobel Prizes in the United States? Based off that. Do you think eating chocolate causes people to be smarter? No. Correlation. Heck no. There's a correlation. Okay? And if you look here, this is very important. Correlation does not mean causation. Just because two things happen to happen at the same rate, pretty strongly, does not mean one caused the other. So we're going to look at some silly examples. Here are two chartings of information. Number of people who drowned by falling into a pool, and films Nicolas Cage appeared in. That's a pretty, look at the paths. Pretty similar paths. Look at the correlation. 66.6. Pretty strong. That does not mean if you go to a Nicolas Cage film, you're going to fall into a pool and drown. So, correlation does not imply causation. Here's another one. Very closely entangled here. Number of people who died getting tangled up in their bed sheets at night, and amount of cheese eaten. Okay? There's a strong correlation. Look at that. 94.7%. That's a huge correlation. It doesn't mean one causes the other. Eating cheese will not make you suffocate in your bed sheets at night. Long notes, getting through it fast. Okay, this is the math of how you actually calculate R. We're not going to do that, but just so you see where it comes from. This is the summation of the z-scores of x times the z-scores of y divided by n minus 1. Now, since this is based on standardized units of each thing being multiplied, it doesn't matter whether we do x times y or y times x. 5 times 3 is the same as 3 times 5. Also, there are no units. So it's not inches, feet, seconds. There's never units. And this is important too. If there's an outlier, it'll actually make your correlation go more to the extremes. So having that outlier, like yesterday with candy, we had the outlier, I think it was like peanut butter M&M's or something, that actually would make our R get higher. If we took it out, the R would get closer to 0. That's important. And we're going to be using our calculator. So everybody get your calculator out. Now, we have to do one thing real quickly. So, everybody hit second 0, catalog. You have to do this on your calculator, otherwise everything won't show up. Once we do it, we don't have to do it again once we change batteries. It's going to take a little while. You got to scroll down until you get to the D's. And you're looking for the word diagnostic. There you go. So there's diagnostic on and off. We want to go to diagnostic on and hit enter. And hit enter again, still says done. Now we're good to go. You want diagnostics on so it gives you all the data you need. Now, here's some teams, their touchdowns and their wins. We're going to see if there's a correlation. So everybody go to stat, hit edit. Now, remember, to do this, everybody look, go up to L1 and hit clear. And then come back down. If you have anything in L2, go over there, go up and hit clear. And then come back down. Okay, everybody in L1, put in these numbers. 58, enter. 49, enter. 31, 24. Then arrow over to 2. And then put in 13, 10, 7, and 5. Now, we have these 4 teams, and we have their touchdowns and their wins. Now, we're going to follow these steps right here. Okay? You have it on your list. So hit stat again, everybody. Okay? We're on step 3. We're going to go over to calculate. We're going to hit number 8. Now, don't hit enter yet. You want L1 and L2. That's where we just put the data. Under frequency list, leave it blank. And then on this one, we're going to use this later, like next in the rest of the unit. But right now, you're going to hit the alpha and trace. And we're going to pick Y1. And basically what we're doing is we're storing the information for this line in Y1 so we can graph it later. We don't need that now. We're just practicing it. Then hit calculate. And you should get this. You should get an A of negative 0.19, B of 0.22, R squared of 0.98, and R of 0.99. So what's our correlation? R equals 0.99. Is there a strong correlation between touchdowns and wins? Yeah, there is. Okay, it's pretty strong, 0.99. Now, what would happen if we switch touchdowns to X and Y axis? Nothing. Because remember, 5 times 3 is the same as 3 times 5. So it would stay the same. And does R mean touchdowns or wins? It doesn't mean anything, because R does not have units. One more. All right. Now, this one's going to take a little more work. This is our data from yesterday. So if I take your calculator, hit stat, go to edit, go up to L1, hit clear, come down. Do not hit delete. Go over to L2, up, hit clear, come down. Now come back to L1 and put these 12 numbers in. 45, so forth. Everybody just put them in. Don't go too fast. Make sure you're checking them as you put them in. 79. If you beat me, go over to L2 and start entering those. After you hit enter, you should have perfectly lined up, 48,350 on the last one. So we just run our stats again. So we hit stat. We go to calculate. We pick number 8. L1, L2 should be the same. Leave that blank. Alpha trace, Y1. Just hit enter a few times. Be at 0.618. So R equals, we rounded it, 0.62. Still pretty good, passing. Okay, moderately strong. Now, based on what we talked about on the previous page, suppose I decide to bring a healthy snack in that has 19 grams and 95 calories. That would be an outlier. Will an outlier make that R go up or go down? It will make it go up. Very good. Let's prove that. Let's take our calculator back out. Go back into edit. Now, you have to go down. The last one. Whoops, went too far. You can also go up twice. And put in 95. Enter. And then go over here, put 19 under X. Enter. I'm going to add that. And then we're just going to run our stats again. Stat, calc. Whoopsie, wrong one. Stat, calc, 8. And it went up to 0.73. Okay? So yes, it did make it go higher.